Comparing more than two dependent variables using SPSS. Okay, these are assumptions for ANOVA. Okay, we have a few ANOVA. So this is the assumptions since ANOVA is the parametric test. Okay, so first, of course, the measurement scales. We need to ensure that the data is ratio or interval. And then we need to check the normality test. If normal, we can proceed. If not, we need to opt to non-parametric test. And then we need to check on the homogeneity of variance. We need to ensure that it is homogeneous. Okay, so the steps for the repeated measures ANOVA. Okay, state the hypothesis to compare means. Okay, run the repeated measures ANOVA using SPSS or any statistical tool, and then interpret the results. Okay, so you should write F, and inside here is the value of the F within, while here is the value of the F error. Okay, and this is the value for F, while here is the value for P. Okay, and then if there is significant difference, we can interpret the effect size. Okay, so the partial eta squared between subject, and then compare the result with this indicator. Okay, if there is a significant difference between the means, we need to run the post hoc test with Bonferroni adjustment. Okay, and then we should interpret the post hoc test results. Okay, next for the Friedman test. Okay, first we need to state the hypothesis, and please remember that it's not comparing means. Okay, and then we need to run the Friedman test and then interpret the result. Chi-square in the bracket, we should insert the df value here, and then here is the chi-square value, and here is the p value. Okay, and then interpret the effect size based on candles W. Okay, and this is the calculation, and this is the indicator. Compare the result with the indicator. Okay, so if there is a significant difference, we need to run the post hoc test with Bonferroni adjustment. Okay, using Wilcoxon sign rank test. Okay, and then interpret the post hoc test results. Okay, so that's all the best.